intercept form. Okay, so we're going to look at another form. Notice I didn't call it transformation form. I called it intercept form. Okay, so this one is y equals a. That's the same a value from the transformation form. Parentheses, x minus p, parentheses, x minus q. Kind of looks like it's factored. So right next to intercept form, I'm going to write factored because that's the skill that this one connects to. Factored form. Now, what does the A, P, and Q do to the graph? Well, the A tells me how it opens, up or down, just like it did before. And it also still stretches the Y. Same thing that we just did. Exactly the same thing. Okay? This one, okay, is the x-intercept. Okay? So that gives you P, comma, 0. Remember those characteristics you were just filling in on that very first question? X-intercept, Y-intercept. This is the x-intercept. Q, comma, 0. It comes from the solutions for factoring. So remember, x-intercepts, solutions, roots, and zeros. Those are all the same thing. Literally, they're all the same thing. Yes.
So do you have 2 points now?
So now we have 2 x-intercepts. Yes, they're both x-intercepts. Okay. So I'm going to draw just a little picture here, just a little one. Okay. And I'm going to try to draw a parabola symmetric. So I'm going to put a vertex dot here. Dot. Doesn't need to be like coordinates, okay? But I'm going to try and draw a parabola symmetrically. So I'm going to draw half of it. I'm going to try to draw the other half of it. I just want it to look symmetric. So I'm going to draw my little symmetry line down the middle because I'd like to see it. Okay. So notice right here we have the 2 x-intercepts, wherever they happen to be. I would like to know where the vertex is because that's one of the important features of the parabola. Like, where's the vertex? That's the min, it's the max. Like, I need to know. Can anyone give me like an English sentence, like regular words on like where the vertex is? You can just look at the numbers. Sasha?
In the middle?
In the middle, yes. Yeah.
Can you add the numbers, or like add the 2 points and then divide by 2?
Yes. Does anyone remember that thing called midpoint?
Somewhat.
That's okay. The middle of the x-intercepts. Isn't it supposed to be symmetric? Look. 1, 2, 3. 1, 2. It should be symmetric. So it's the middle of the x-intercepts. Okay. So the axis of symmetry, right, the middle, is add the numbers and divide by 2. Now, could you do it like visually by just looking at the picture? Certainly. Okay? Could you do it arithmetic where you add the 2 x-intercepts and divide by 2? Yes. Okay, now I need to know where the vertex is gonna be. P plus Q over 2. Big fancy numbers here. Plug it in. Or plug X in. Okay? Plug X in. You have the X coordinate of the vertex, right? Because it's the same as the axis of symmetry. So plug it in.
Do you multiply them?
Let me do the example and then ask that question. Because I'm not sure what you're asking if I'm multiplying. Okay.
Where do you plug X?
Oh, to the equation, right? To the equation. Plug in X to the equation. All right. Examples. All right, so I'll do the same thing. I'll work through the whole thing, and then we'll do it again together so you can write it down. I think I'm going to end up out of space here, so. Okay.
Why would you do that?
Okay. Here's our example. Y equals x minus 4, x plus 2. Okay. I'll make sure you have it written down and then I'll do it. Okay, so you're going to watch and then we'll do it. So the A value is 1, so it's going to open up like a cup. There is no stretching. The x-intercept is right 4 and left 2, okay, which means 4, 0 and -2, 0. That's what I learned. So -2 and 4. And so I'm looking at this. I'm like, okay, well, it's a parabola. So symmetry. 1, 2, 3. Okay, there's my axis of symmetry, which is at x equals 1. There's my axis of symmetry. I did it visually. How do I actually place the vertex? You plug in the number to the equation. So I get -9. So that's down here. And, well, there it is. Now, I need 5 points. Okay, I need 5 points. I only have 3. Well, guess what? The A value is 1. So the 1, 1, 2, 4, 3, 9 still work. You can still use those. So 1, 1, 2, 4, 3, 3, 9 actually gets me right to those x-intercepts. That's pretty convenient. Okay, so you can plot more points by using those numbers from the parent function. It's still a parabola. It just wasn't transformations that I used to get here. Okay. All right, so now I'm going to do it again, and this time you can write it with me. Question. Can you pass those back? Probably not. We're probably only going to do this one and one more. Okay, here we go. So I'm going to start with opening up because it's a 1 in front. And my x-intercepts are 4, 0 and -2, 0. Right? One from each of the factors. Okay? Notice that they're opposite, right? Right 4, left 2. They're always opposite from the parentheses. Okay, so I'm going to choose to put those points on the graph. Because visually, I'm like, well, how do I get my vertex? Okay, well, my vertex is in the middle, the symmetry line. So x equals 4 plus negative 2 over 2 equals 1. Okay, so you can do it, right, algebraically. You can also just count. Just count to the middle. It's still symmetric, okay? When one method works, great. If it doesn't, try another way. So this is x equals 1. How do I actually get my vertex? Because you have to have the vertex no matter what, okay? Well, if x equals 1, then y equals plug it in to the actual equation. Okay, so y equals negative 9. There it is.
So do we just put the points there?
Okay, so I only have 3 points. I do need some more points, okay? Now, notice that you can still do 0, 0, 1, 1, 2, 4, 3, 9. So you can plot any other points that you want. So over 1, up 1. Notice that this was a 1 in front. That's why the values aren't changed. 2, 4, 3, 3, 9. Actually gets me to my x-intercepts. You could also count backwards to get the vertex. Because if you go over 3, it's 9. Okay? And reflect. Yes, question.
So are the 1 and negative 9, is that the, what is that, like, what are those?
Oh,
points
that's
called?
the vertex. So the vertex is 1, negative 9, right there, which is on the axis of symmetry. There we go. All right.
There's 2 points that you did.
These points here came from the counts. 1, 1, 2, 4. Yes.
So if in front of the, if y equals like 2 times x minus 4, we would do all that, and then we get the extra points, we would do 0, 0, 1, 2, 2, 8.
Yes, yes. Yeah. Okay. We will end with one our last example, right? Because I think then it will be time to clean up. I know.
Killing the trees and making it too little.
Killing the stickers. Okay. Graphing just takes a lot of space, guys. All right? Graphing takes a lot of space. But it's better than making you draw the graphs in your notebook.
Thank you.
You're
Also
welcome.
better than the sticky notes. that we-
Yes, yeah, these are the best ones I found.
Other math teachers use.
I know. Okay. Yes.
Oh, I see.
Yeah. Do you need more? Oh, yeah, sure. Okay, here we go. Question 2. Okay. Yeah, the only way to learn to graph is to actually do it. Here, there you go. Pass them backwards. Do you need more? There they go. They got one more. Okay. What if there's a number? Minus 1/2 x minus 3 x plus 5. Okay, I'm going to do it twice. Here we go. Down and 1/2 times y, because I have to shrink it or compress it. This one's gonna be an x-intercept of +3 and -5. So -5 and 3. And I 1, 2, 3, 4. 1, 2. Okay, so visually, it appears as though -1 is the center. So the axis of symmetry is -1. I prefer to do it on the picture. I feel like it's less challenging, or it's less mental energy to just put it in the middle of the 2 points. Okay. The vertex means I have to plug it in. -1/2, 1 minus 3, 1 plus 5. All right, guys, you have 3 things to multiply. I suggest you pick 2 of them at a time. Yeah, hold on, I got you. Yep. Okay. So I'm going to go -16, and then I'm going to multiply, so I get +8. So the vertex is at -1, which is on the line, and +8, which makes a whole lot of sense because that vertex better be at the top if I'm supposed to open this graph down. Vertex better be at the top if this is supposed to be down. You gotta connect all the dots. Okay, now, could I count some more points? Well, over 1, down 1/2. Over 2, down 2. Over 2, down 2. Over 3, down 4.5. You're going to get so good at counting the parabola numbers. Over 4, oh, down 8. Gets me back to, right? Okay, there's your parabola. Bloop. I'm going to do it again. Yeah, I'm going to do it again. Okay, here we go. It's opening down, and I have to multiply the y's by 1/2. I have my x-intercepts of 3, 0, and -5, 0. My axis of symmetry is in the middle. Okay, so I do this, toot, toot, toot. I count to the middle. 1, 2, 3, 4. 2, 3, 4. And right down the middle. Yeah, you can start. Okay, so x equals 3 plus -5/2. -2/2. Y equals. Sorry, I'll go faster. Okay, 8. Whew, there it is. Plot your points. 3, 4.5. I don't like the half points, but I'll show them. Okay. Okay, guys. Yay!